Hey everyone, this is Madhav. We're finally at that part where we can learn about real AI libraries. Today, we're going to be learning about LangChain, which is a Python library to help us build chatbots. It's called LangChain because, these large language models, AI models are what we're using. And the chain part, you'll see soon that it comes from the fact that LangChain simplifies our life, allows us to combine a lot of different components together without writing lots and lots and lots of Python code. It is convenient. The only problem with LangChain is that it breaks so much, and the reason is because it's always being updated. Chatbots are hot right now, everyone's developing new features, so literally between me creating, all of these workshop files in the same GitHub repo as usual, linked in the description, uh, in between me creating the files and recording this video, LangChain got updated and everything broke and I had to go back and fix it. So it can be annoying to work with. That is my warning to you that decide to use, the actual GitHub repo and these files. You can do it with VS Code. I'd recommend it. You need to do it in a real software job. Only problem is it's hard to learn because of LangChain being finicky and like trying to install the right version of the library and whatnot. So for today, I have also created an alternative for newer people. We go to kaggle.com. You want to register and I will put links to these notebooks in the description. You just go here, presumably you've registered, and you just click on copy and edit, and you'll be good to go. So, especially if you're a beginner to Python virtual environments, I'd recommend let's do that for today. With that out of the way, let's get started. So, I clicked on copy and edit, and I have a copy of this notebook over here. Now, the first thing that you need to know is LangChain. It is organizing code for us, but it doesn't have any AI models. Companies like OpenAI or Anthropic, they have AI models, so we can send them data and then get responses back, just like we can, go to chatgpt.com, type in a question, get a response back. Now we're going to learn how to do that with Python code. So as you'll recall from the very first workshop, when we have these URLs, these websites that we can go to, send them data, get data back, we call those APIs. So today we'll be using the Python, we're going to be using the OpenAI API. To do that, we need to pay for some resources. So if you want to, you can pay, I think it'll cost you around $5, and get an API key, which is like a password telling OpenAI, hey, I have permission to use this. Don't get any ideas. I'm going to delete this by the end of the video, obviously. You'll need your own API key. Alternatively, you can just focus on me, focus on the concepts in LangChain if you don't want to pay right now. For the people who are looking for an API key, so this password to access the OpenAI API, you can do that by going to platform.openai.com. At first, you won't see all this. You'll need to log in the top right. After you log in, you can click on the settings button and it'll take you here. You go to billing and add a little credit balance. I think the minimum amount is $5. And then you go to API keys, create a new secret key, name it whatever you want, select a project, and then create key. It will give it to you to copy. You won't be able to see it ever again, so make sure you save it in a safe place. Now, in these workshops, on Kaggle especially, I'm doing something very insecure. I'm just saving the key right here. Don't ever do this. No real programmer would ever do this. If you go to the GitHub, it describes much more thoroughly what the best practices are to save these API keys securely. So be careful about this in any kind of real job. For today, though, we're just going to get started. So um, if you have gotten your API key, just paste it in here. Make sure it goes between the, quotation marks. Then we can run a cell. So just click on the run button. It might take a little while for you. You'll see like, oh, it's getting ready. So you can pause the video until it's ready. Anyways, once that runs, you'll see like a number pop up here instead of empty square brackets. So that's telling you, okay, I got my notebook running. One thing I should advise you, so on the right, you have this sidebar. scroll down to the session options section and make sure you have your internet on. You need that for this particular workshop because we need to obviously get data from the OpenAI API, return it, and so on. You will need to verify your Kaggle account to do this. So you can go to kaggle.com. If you click on your profile pic on the top right and then click on settings, there's a place where you can verify your account with your phone number. So you'll need to do that if you want to follow along. With that said, let's dive into actual LangChain concepts. So the first thing we're going to do, we're going to load all the libraries we need. It might take a lot longer for you guys, so give it a minute. Now, when you run this code block, if you see like a checkbox, that means everything's all good, we're ready to get started. As I just said earlier, LangChain, what it does is it connects together lots of different components related to these large language models or these AI models. So it's like a, chain of these different components. Just to help you appreciate that, let me show you the manual way of like writing Python code for everything we want to do. If we wanted to access this API, send it some data like a question to answer, and then get a response back, we'd need to do all sort of login settings, we'd need to get the data formatted right, we would actually make the API call, we would have to check, did it go through properly, then extract the actual response from the chatbot, and in the end, after a whole lot of work, we could ask a simple question like, hey, write me a haiku about debugging code. And then we run all of the Python code. Eventually, we get back a response. Now, in a real life app, this is not sustainable, right? Like we have to make lots of different API calls. It's not just one. So it's not sustainable to write all of this Python code every time we want to use a chatbot to answer any tiny question. This is what LangChain helps with. All of these manual steps of like logging in, having the data formatted properly, doing the network stuff, unpacking the data, error handling, all of it LangChain will take care of for us. So let's take a look at one example. Here is equivalent LangChain code to do the exact same thing. LangChain is a library that has implemented a class for us. It has some useful attributes and methods and whatnot. We can easily specify which AI models we want to use. We can specify some settings for the models. The particulars don't matter, but you can see that the code is a lot easier to read and it's a lot quicker to type out. And in the end, after we have created this class instance, so, specific library-specific code has been created. That library-specific code has a convenient invoke method for us where we can just type in whatever question we want and we get back the results we're looking for. So this is much, much better than, all of this Python code. This is the main advantage that LangChain has. Hopefully that makes a little bit of sense. I'm going to now move on to showing you more and more advanced features of LangChain to show you other ways that LangChain can make your life easier and allow you to get back answers to questions from chatbots. The next thing we're going to look at is something called a prompt template. Now here, we're typing in a manual question every time. So let's say I didn't want a haiku about debugging code. Let's say I wanted a haiku about something else like biochemistry. I'd always have to go back to my code and change all of the, questions I'm asking, and this is not very maintainable. Especially think about like some user. Let's say you have a service that's like they're helping artists, get out of writer's block. And, the artists, they are working on different things, right? Maybe one person is writing a book about these sciencey topics, while another is writing about, visual arts. It won't make sense for them to like have to go and change the code of this, service you're providing to help them get unstuck and get ideas every time they want to get some, haiku ideas about some different topics. So what we'd ideally like is, this topic thing, we want it to be interchangeable. Different users who want different, topics, they can just change whatever they want. Maybe they fill out a form on a website, and then we can just take in whatever topic they submitted and send it to the AI model. This is what prompt templates allow us to do. So a prompt template, it might look a little bit scary, but the basic idea is very simple. These three quotation marks just are, Python syntax for a multi-line string, i.e., it's spanning multiple lines. But setting that aside, a prompt template just has a question that we're asking the model, except you can see we have these, curly brackets here with different placeholder values. And over here, we call those input variables. These need to match, right? What these allow us to do is we can take this prompt template and exactly like I was talking about above, if we had, a placeholder like some topic, we could send in some data, replace, all of this stuff with different topics for different users. Let me show you that so that it becomes a little bit more clear. So we have this question that we're asking the chatbots, but we need to fill in, what these placeholder values will be, different genres, characters, and settings for writing a story. So the way that we're doing that here is first off, I am, defining a few genres, settings, and, characters to resemble, okay, here's what like different users might submit in a form. And over here, I can just use this Python syntax. It may look a little bit bizarre, but we just have a class instance. We're calling it format method. And this star star scenario thing is just taking all of these values and passing them in to this prompt template as it would like so that we can replace the genre with, let's say, sci-fi, or the character with a robot barista, or in the setting with Mars colony. So let's see this in action. I'm going to comment this out because it's unfinished. And I'm just going to run this. So you can see, it is creating something that is based on what I said. So it is a sci-fi based story, it is about some future, da 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 da, there's a robot barista involved, and so on and so on. What I'd encourage you to do is pause the video for a sec if you're following along and, try filling out a couple of different stories. Okay, I'm assuming you've had time to pause. So let me try this here. I want a fantasy story about an old wizard, and the setting is, let's say, Harry Potter world. Now let's generate two of these stories. So the first one is about sci-fi, the second one is about fantasy. So again, the key idea here is this prompt template is allowing us to reuse this one, question that we have formatted for the chatbot, and then shove in the different values that we want into these placeholders. So this allows us to reuse these prompts, and it also allows us to support different users that want different things without, them needing to change the code of everything involved. So these are two very basic features of LangChain that you'll be using all the time. What I'd encourage you to do is maybe, pause the video, review the code a little bit, because yes, it can be a bit much. There's also LangChain docs available, so you can always search up LangChain prompt template and you'll see more examples. One last common feature of LangChain that I'll talk about in this basic notebook, we also can combine different things, so different classes, from prompt templates to, the other class we saw earlier, like this chat OpenAI class. Later on, we'll see like different, databases that we can connect to, different tools. LangChain, again, it chains together these different components. So it has a LLM chain class. What we can do with an LLM chain is, we can combine different things together. In this case, we're combining an LLM, a large language model, so that's the actual chatbot that we initialized, with various prompts. So we can take the same chatbot, give it these different prompt templates, one to, create a short story, and another to critique a short story. And now we have, it's almost like we have two different chatbots because we've customized them with different prompt templates, even though we're using the same, model. You can imagine as we add more and more components, we learn about more parts of LangChain, this type of thing becomes very convenient. So here I can, pass in a topic to this function. It's going to first go and make a story about it using the story chain LLM chain that we just created. And then it will get a critique by taking the output of the, first chatbot and sending it into the second. So I'm going to run this over here, and you'll see that it generated a story and then it got a critique. So you can see how I can reuse certain components, in this case just the LLM components, but in the future more and more components by using these LLM chains. And that is the key idea of LangChain. Write less Python code, reuse more things as much as possible. I hope that makes sense. What I'd encourage you to do now is pause the video and try out this little challenge to create a useful, chatbot with, again, two components. One is going to try and generate product ideas for a business you might start. Another will analyze how good those ideas are. So take a second, pause, and take a look at the to-dos. Um, Hopefully you have some time to do that. The one thing I will say is there are solutions right here. So for now, I will skip over the solutions and the other exercise for the sake of time. But you are free to, check them out on your own time, and the solutions are also here. Now, that explains different basic components of LangChain. You're going to be using this in every single chatbot you ever create. Now let's look at some more, useful features that are a little bit more domain specific. So I'm going to jump over to this intermediate notebook where we're going to learn about two new features, data loaders. They allow us to fetch data from out there on the internet, and output parsers, which allow us to tell the chatbot exactly which kind of output we want so we can get more reliability. Again, this URL will be posted in the description if you want to follow along. And again, you will need a API key if you want to run the code. So for now, I'm just gonna fetch my API key from over here, and let's paste that in the other tab. Okay, and again, I will press run. It will take a while for this to start up, but after it does, you'll see that you have a number here, as I said before. So let's reset it. Again, important, you will need to have your internet on. Okay, so I'm going to load all the libraries we need. This will also take a while. When it's done, you will be able to, as before, run this one cell. If you see a checkbox, everything's good. If not, try asking ChatGPT about, what might be going wrong. So now let's talk about data loaders. So in the, basic notebook, we were always doing kind of uninteresting stuff, which was like, we would always have to type in exactly the question we wanted and all the things that we were sending to the chatbot ourselves. Now, this allows us to do some basic things, but, sometimes you just want to, let's say, analyze a news report from some news site on the internet, or go find out which products a company offers based on visiting their website, or check, what is a YouTube video talking about. So when we're doing this, we want to get data from different internet sources. Luckily, LangChain has a bunch of that taken care of for us so that we don't have to write a bunch of annoying Python code. So these things are called data loaders, document loaders, and they come in different flavors. So for example, there's a web-based loader class. Again, it's not magic, it's just a class that's built into this library. And with it, we can configure it with some URL. So this is a special URL that goes to a random Wikipedia page. And we can call the load method built into this class by the people who created the LangChain library. If I run this, you can see I get a random article about some person named Daniel Ribeiro. If I run it again, I get something about a town in Phocis, a Greek town. Seems interesting. Anyways, a lot easier than me trying to figure out the code I would need to write to get random Wikipedia articles. Similarly, we can try and get, we can get other documents and then use the data that we find to ask a chatbot questions. So here I'm just, asking questions about a random Wikipedia page, but let's say in past internships, I'd go get data about more useful things like a company website and help investors understand, what does this company do? So after I've gotten, all of the data if of the website in question, I can again use some built-in classes in LangChain to create a quick prompt template. You can see I have a question placeholder and a content placeholder. And then I can call llm.invoke. Again, llm is this thing that we instantiated up here, where we take this prompt. So, this question, send it our data. So let's say our question is, what is this article about? Our content is, what we just fetched from Wikipedia. And if we run this code block, we have some kind of error. Let's think about why we have an error. Syntax error. Did I change about something? That's odd. Anyways, so you can see here, it takes the data from the Wikipedia article, and then it gives me a good answer. Whereas, like, if I just asked it about this random town in Greece without any context like this, I probably wouldn't do a very good job. Now, below this, there are a few examples just repeating the same idea again and again. So here we're loading some data from YouTube, given some kind of class that they've created for us that is convenient and helpful at loading YouTube videos. Over here, I have, of course, picked the very best YouTube video for this demo. We are going to get rickrolled. Anyways, let's say I got the description of the YouTube video. And over here, I'm doing a very similar thing. So I'm reusing the prompt template and I'm asking it to summarize the main topic of the video. I pass in the description and it's able to give me the answer I need. The last thing is about fetching a bunch of news articles. So this is a link to a bunch of real-time, latest news articles for today. They're published in some format called an RSS feed. We don't really care because luckily LangChain has got our back. This will take a little bit of time, actually quite a bit of time, because it needs to go and get the content from all of these different articles. So it has to visit a lot of websites. But once it has done that, it will show us that it's found 56 articles and, it's found some latest thing from today. If I wanted to know, what are the top 3 articles about today, I could just ask the, chatbot some questions and it will talk about, different content that it found. So I think this is very cool. It makes our chatbots, pretty useful. And you'll often be using it when you're creating your own chatbots, demos, things like that. So these data loaders are great. They save us a lot of work. And there are many other formats besides, the videos and the websites and these news feeds. You can search up LangChain document loader or data loader, and you'll find all sorts of different ones. Some will connect to, for example, Google Drive or Google Docs or your email or whatever. So you can very easily with LangChain get data from a lot of useful sources. Let's keep moving on. So this is about getting the right input to the chatbot, getting the chatbot interesting information to answer questions about or summarize or, do other useful things with. The other half of that is we need to make sure the chatbot gives us reliable outputs. and that's where output parsers come in. You'll notice right now, the chatbot is just giving me free text. So this could be useful, it could be not. For example, I mentioned I worked at a company where I had to analyze, let's say startups that investors might want to buy. And to do that, I can't just give them general text like this. They want to know very specific things like how much is the startup earning? Who is the founder? What kind of, products do they have? So I need to organize my information in a different way. Output parsers help with this by letting us basically just create a class that defines, okay, here's what we're looking for. Chatbots, at OpenAI, please make sure you follow these instructions explicitly. We're going to make sure to check your work. So again, I'll load in a bunch of useful classes that LangChain has defined for us. But here's what a structured output looks like. In this case, I'm creating a movie review and I want a few fixed fields that I want the chatbot to definitely cover. So I definitely wanted to give a title, a numerical rating, which is why we specify this type. We're not just saying, here's the name of the variable. We're saying, okay, this one is a piece of text. It's a string. This one is a number. The pros are going to be a list of strings. Each pro will be different. Same with the cons. And overall, do I recommend it, true or false? So if I create a class like this, I can create a output parser. An output parser does two things. The first thing it does is it will, when sending my question, this question, to the chatbot, the parser will create, instructions and add those to my question so that the chatbot knows exactly what I'm looking for. The second thing it will do is, we can call parser.parse on the response content and make sure that what the chatbot outputted is exactly what we were looking for. So it will, validate that the output follows the format we wanted. To make this more concrete, let me just print out the prompt for you so you can see. Um, let's see, prompt dot, let's see what I'm sending in. So I'm sending in this question to the chatbot. So I'm gonna say question is equal to that, and let's print out sending to chatbot, and we're doing this question that we're sending in. Okay, so you can see we have first of all the part that I defined. So write a review for the movie The Matrix, but everyone is a rubber duck. So that's the part I wrote. And after that, LangChain took care of a lot of other stuff and it added a lot of other instructions for me, telling the chatbot exactly what I was looking for. Afterwards, it also, when I called parser.parse, it also took the raw text output and organized it, checked to make sure that the chatbot did give me a title, a rating, some pros and cons, and finally a recommended, which is a true or false. So you can see how this would be useful. It makes your responses more reliable. And in fact, in any commercial, setting, you're basically almost always going to be doing this, okay? It's never really feasible to have a commercial product and you let AI models create whatever kind of output they want. You need to constrain them somehow, organize them somehow. So a lot of the time that people spend working in prompt engineering jobs, for example, is by changing, these output parsers and the prompt templates that you see here so that we get more reliable responses from the chatbots. With all that said, there are a few exercises again here with some solutions as well. So I'll leave you on your own time to try it out. It'll help you combine data loaders and output parsers, which again, extremely, extremely useful to get any sort of reliable product. In the meanwhile, though, on my end, I'm going to jump over to the last workshop. Again, I'm going to link it in the description. So this workshop, it's going to talk about some last final things that you might want to know, some more advanced features of LangChain that will come up. One of them will come up very often, which is a vector store. So this will allow LangChain chatbots to persist data over time. What do I mean by that? Well, when you go to ChatGPT and you have a conversation, right, you might ask follow-up questions. You might want to ask about something that you were doing yesterday. Where did that conversation go? So vector stores are like our databases. They allow the chatbot to have memory of useful data that it can use to answer questions. So that's going to be very important. And these other things, well, less important, but less generally important, but they are very useful and make the chatbots more powerful. Let's get started here. So again, I'm gonna, get started by installing all the libraries I need. Might take a little bit of time to get the draft session running, and so on and so on. After all of this is done, again, we're doing this insecure key thing, so I'm just gonna copy over my key from here. Don't do this in real life, just for this workshop, so that we can be fast. So I'm gonna paste this here. All right. And finally, that same thing that we were doing earlier, where we, you know, run this, and hopefully we get a check mark saying everything's good to go. All right, let's get started now. So the components that we're going to learn about, so different, again, classes in LangChain. First, we're going to learn about tools and agents. Tools will allow LangChain to connect these chatbots to external things like, let's say, I want to access Wikipedia articles, I want to access a search engine, I want to access some kind of calculator or database, anything like that. So these, can be very useful for chatbots. In LangChain, tools are very easy to do. You can actually just create any function that you want, and you put this syntax. It's something called a decorator, which you can search up if you're curious. But at the end of the day, it's just a function. These things, they're called type hints. They're not usually required in Python function syntax. They're just like indicating, okay, this function takes in something that is a string, and it also returns a string. You put in a docstring, which is like a comment that helps the AI model know, what does this tool do, and when should you use it. And finally, you can put in whatever code you want in there, and then return whatever you want. So for example, I can do calculator.invoke, some math expression, and I get 105. But if I use the incorrect syntax, then I will get like some kind of warning. Now, when I say I will get, well, ChatGPT will get it. So I will give these tools to the chatbots so that they can use it. They can see all of these type hints and these descriptions, and they'll get back, either the results or some error messages so that they know what they're doing wrong. Similarly, I can do, something with Wikipedia. Let's say I want to get external info. So I can create a tool about it where I um, call some pre-built libraries, again, LangChain created to be convenient. And I can run a Wikipedia search on some topic and then return the summary I get back. So for example, if I want to know about Python programming, I get back a bunch of pages with some summaries related to Python programming. Now, these tools, they seem interesting, but what do we do with them? To allow chatbots to use them, we need to have the chatbots act as agents. The key idea with agents is that they can operate in multiple steps. So in the past, when I would ask ChatGPT to answer a question like, hey, what is this thing about? It does that in one step. I give it my question, it gives me a response, and that's that. With agents, the difference is that it will operate on multiple steps. So it will start off with my question, and then it will have the option to answer my question and be done, or maybe use one of these tools that I will give it, or do something else. So it can over time react to what's going on and update what it's doing. Let me show you so that it is less abstract. Again, there's a useful class that LangChain has created for us to create an agent using this kind of framework where the agent reasons, then it picks an action. It stops and waits to see, what happens after it took an action, and then it repeats. So this is called the reason and act pattern. Anyways, I'm going to create this agent. You can read more about it online by just, searching up LangChain React agents. Now, let me show you an example of like where this might be useful. Let's say I wanted to ask this complicated question. What is the population and GDP of Tokyo according to Wikipedia? So first, it needs to get some information from Wikipedia. Then I'm telling it to do some math. Assume like 5% of people in Tokyo are tourists, and then, use a calculator, figure out the GDP per tourist, and so on and so on. So there's lots of different steps involved here. And if I just asked ChatGPT, it won't give me a very accurate answer because first of all, it doesn't have the information from Wikipedia. And second of all, it's, well, I don't know if you've tried using chatbots as calculators, but they're usually not very good. But with this agent set up, where we have the chatbots, but we also gave it, these two tools. Now, if we run this, so we'll do agent.invoke, and then we'll pass in, the question. What you'll see over time is the code will fail to run. I wonder why. Just being slow. So it'll start off by asking a question, and then over time, the chatbot will create different, it will take different actions. So here, the chatbot looked up, some Wikipedia info on Tokyo, and then it, had this idea, okay, let me try and use the calculator, but, it had some errors. It was trying to pass in GDP, but it didn't pass in the number. So then it thought, okay, like I gotta adjust this, I gotta put in actual numbers. So it reacted to what went wrong, tried to use the calculator again, and it gave back an answer. Now this answer doesn't seem very reliable because we're using a very, very old and simple chatbot, but you can see what's cool here. The agent, it was able to break down the question, it was able to call the different tools, it was able to actually react to, some kind of error happening and then fix the mistake that it had. And in the end, over time, it was able to give a final answer, which was better than if we didn't give it any tool or give it any agentic setup at all. So agents can be very useful. The only thing I'd mention is like, because they're acting over time, right? They're taking multiple steps, they're always going to be more expensive and slower. So they're really only suitable for problems that are complicated, which, they come up, and that's when you need to use agents. But they're not going to be useful in every single problem ever. Like, the basic problems that we saw, like generating a story, we wouldn't want to use agents, perhaps. Okay, so those are the first two tools. So we learned about tools and agents. Now we're going to learn about something called a vector store, which is that generally useful way to store relevant information. Let me talk to you a little bit about it, and then we'll wrap up. So a vector store is a way of storing text efficiently. So let's say in the prior, um, notebook, we went and found all of these Wikipedia articles and these YouTube video descriptions and whatnot. How do we store all of this info and how do we retrieve it later on when we need, let's say, some user asks about Greece and we're like, oh, I found an article about some Greek city. Let me go find that again. How do we do that efficiently? The answer is a vector store. So with a vector store, instead of storing all of the text, which would be huge, what we do is we compress all the text into numbers. There's some magic which is complicated. I can't explain all of it, but it allows us to turn text into numbers, into lists of numbers in particular. And the reason why I say it's magic is because the way this process is done, it allows words that are closely related to end up with numbers that are closely related. You can imagine like this is a point in 3D space because I have these three numbers representing each word. Well, the words representing these, pet-like things are close, and the words representing these technological things are close. So the key idea here is vector stores, they will take some text, they will embed it, that's the process of turning them into these lists of numbers, in such a way that similar texts will have similar lists of numbers, and different texts will have, more different lists of numbers. Why is this useful? Well, later on, when we are trying to figure out, okay, the user asked a question about, let's say they asked a question about parrots. Do we want to, get some of the prior content, like let's say a Wikipedia article that we got about pets, or do we want to get, the Wikipedia article about computers, laptops, software, use that information to answer the question? Well, clearly we want to get this stuff. And the way we can figure that out is, we just take the user's question and we also embed it. So run it through the magic process that turns it into a list of numbers, and the question that the user asked will have a list of numbers that is similar to these pet-like thingies, the pet-like text, instead of the technological text. That's the key idea of a vector store. Turn all the text into lists of numbers and find, get more similar numbers together so that we can treat them as having similar context. So I'll leave you to, read this over and ask ChatGPT if you're confused. It is a little bit of a novel concept. But I'll show you, what you can do with it. So I'm using an embedding model, which is, that magic process that turns the text into numbers. And I am loading some data that I found on Kaggle. So some data about, COVID-19 tweets. So I'll run this cell and it says, okay, vector store loaded, which means like it has gotten all of that parsed data, all of that text, and all of those embeddings, those lists of numbers that match each text. Now, what I can do is I can do a similarity search to find, let's say, a text that is similar to my question. So my question here is I want to find like the most surprising COVID-19 tweets. So if I do a similarity search between all of the documents, so all of the COVID-19 tweets that I have, pre-stored in this vector store, and this question of most surprising, I can print out the results I get. Well, you can see, the results that are similar, they try and use, they get back um, tweets that have similar words. So let's say I use surprising and surprised, like, similar idea. Shocking is another thing, which also shows us, this is not like an exact word search. So that would be what we would have to do if we did not have these embeddings, these numbers. We would have to exactly, do a control F and find the exact word match. And if we don't have the proper buzzword, the exact right phrase, then, we're done for. However, with the vector stores, because we turned everything into numbers, similar numbers, even if they're, slightly different words like shocking or surprised, because they have similar meanings, they end up closer together, and we can retrieve them to answer the user's query. So this is how we can use AI to help us, find a needle in a haystack. But in general, this process is called retrieval augmented generation, RAG, because we're retrieving some data from our vector store. We are sending it to the chatbot, and then we're augmenting or improving the response we get back. So the generated text it gives us back, the generated answer. Here you can see me doing that. So again, useful LangChain classes available. You can look at the docs to figure out exactly how to do this stuff, or just ask ChatGPT. But I could ask ChatGPT something like, okay, what's the funniest tweet in this data set? And it will, turn that into an embedding, a list of numbers, compare it to all of the other tweets, and then it will send the most highly matched tweets to the chatbot, which will then be able to give me, a response. And it will tell me, okay, like, I use this tweet or, that tweet to answer my question. So you can see all of these different components of LangChain are more advanced, but they also make our chatbots more powerful. And really, in the modern day, they're being used everywhere. So if you want, you can maybe stop and try out this exercise. The other thing that I'll mention to you is that we have prepped like a few projects. If you go to this URL linked in the description, where it will give you some, quick challenges to pick an idea and create a chatbot around it. There's already, files that have been created. So there's only 3 Python files. Most of them do the heavy lifting for you. There's only a little bit you need to modify so you can get your hands wet, your feet wet with creating your first chatbot. With that said, I think that finally wraps up most of LangChain, which is a lot, I know. Take some time to review it and play around with it, and I think you'll be able to create some pretty fun applications that you could link on your resume.